Alright, we're getting back into section 2.1 and we're going to look at some applications here of quadratic functions. And we're going to still use some of the information from the previous videos in this section, especially about finding the vertex. Now in this first example, you see it's circled in red, which means that it's a problem that came right off the semester exam review, so you can kind of expect something like that maybe to pop up on the semester exam. We'll see. A projectile is thrown upward so that its distance above the ground after t seconds is h of t equals, not sure why it's underlined, negative 16t squared plus 396t. After how many seconds does it reach its maximum height? Well, now I know why I underlined it, because I need to know what A is and I need to know what B is, because to find the maximum height I need the vertex, and therefore I'm going to use the vertex formula to find not the x value, because the independent variable is t, the t value. Remember, t is equal to the opposite of b over 2a is the vertex formula, and a is negative 16, which means it opens downward, so the vertex would be a maximum. And in this case, b is 396. So this is going to be the opposite of 396 divided by 2 times a, which is negative 16. Negative 396 divided by negative 32, which is approximately 12.4. Now I'm going to round it to the nearest tenth. Many times they'll ask that you round it to a specific value. This one doesn't say. In general, I like to round to 3 decimal places when I can, because that's what they like on the AP test for calculus. But I'm just going to leave this as 12.4 for right now. And that's not the height, but that is the number of seconds it takes for this projectile to reach that height. So it says at after how many seconds? So after approximately 12.4 seconds, it reaches its maximum height. And to find that maximum height, it doesn't ask for it. I would plug this number back in for t here in the height equation, the height function I should say. Here's another kind of a problem that it's very similar, but it's not being thrown straight upward. In this case, we have a quarterback that's throwing a football, so you know he's going to throw it at an angle. A quarterback throws a football with an initial velocity of 72 feet per second and at an angle of 25 degrees. This sounds like a physics problem. The height of the football can be modeled by h of t equals negative 16t squared plus 30.4t plus 5, where h of t is the height in feet and t is the time in seconds after the release. So it was very fortunate that we don't have to go through all the physics to figure out what this formula is. It's presented to us. This information is a little confusing looking, but it's what they use to come up with this. We don't have to worry about 72 and 25. But it does say, determine the time at which the ball will be at its maximum height. Well, it's very similar to what we were just looking at here. We want to figure out the time, so we're going to use the opposite of b over 2a again. T is equal to the opposite of b all over 2a, going to here. A is negative 16 again, but this time b is 30.4. So I'll substitute in, the opposite of b would be negative 30.4 divided by 2 times negative 16, negative 30.4 divided by negative 32, which is approximately 0.95. That's an approximate. I had done the arithmetic earlier. 0.95, so it would be just a shade under 1 second. So it says determine the time at which it will at time equal to 0.95 seconds. Now, it is a story problem, and if I wasn't hurting for space down here, I would probably write this answer out in a short sentence. I could have done the same thing here. It kind of got lazy there. Usually I like to write the short sentence to answer the problem. Now it says in part B though, we want to figure out the maximum height. It didn't ask for the height here, but it does in this problem, so I need h of 0.95, which would be negative 16 times 0.95 squared plus 30.4 times 0.95 plus 5. and I would have to figure this out. So I'd either have to grab a calculator or a piece of scratch paper, and as it turns out, I figured this out earlier, and it turns out to be approximately 19.44. So 19.44, this would be in feet. So to determine the maximum height of the football is approximately 19.44 feet. Okay? All right, and then there's a part C to this problem. It says determine the amount of time required for the ball to reach the receiver's hands if the receiver catches the ball at a point 3 feet off the ground. So if you've ever watched a football game, quarterback throws the ball and the wide receiver catches the ball, or at least attempts to catch the ball. In this case, we're going to try to catch the ball 3 feet off the ground. Well, if 3 feet is off the ground, that means what we want here is we want to know when this equals 3, when the height is 3. So what I'm going to do is I'm going to write 3 equals negative 16t squared plus 30.4t plus 5. That's the height formula, and the height is 3 because that's when he catches the ball. So we want to know what t is, when the time is that he catches that ball. Now, I'm going to bring all of this stuff over to the left side, and I'm going to be kind of lazy. I'm just going to write it out. All the signs are going to change, and I'm going to have to combine some like terms here. But I'm going to get 16t squared minus 30.4t minus 2 is equal to 0. And I'm going to solve for t. Well, that one's not going to factor either. You're going to have to use the quadratic formula, and I believe there's going to be at least one real root here. Let's see what happens. So I would have t is equal to the opposite of b, so that'd be 30.4 plus or minus the square root of negative 30.4 squared minus 4 times a times c. And that's all over 2 times a, which is 16. Well, again, we're definitely going to get the calculator out this time, and we're going to go through all these steps. Well, as it turns out, we get 2 answers. And the answer, when it's plus, turns out to be 1.96, if I'm not mistaken. I wrote it down so I wouldn't forget it. And the other answer, because it's quadratic, it should have 2 answers, you're going to have an imaginary value. Well, that's no good. So it says, determine the amount of time required. It will take 1.96 seconds for the ball to reach the receiver. Hopefully I wrote that out so you can read it. All right, I like that problem a little bit more than the other one here because it really digs deeper into the problem and shows you some of the application of the quadratic function. Now I have one more example here. It's not a height problem. It has to do with maximizing area. This is not that these two aren't, but this is the type of problem that you would come across in calculus, and you would use calculus to make the problem a little bit more efficient, but we can use what we know about quadratic functions here. So it says a farmer has 200 feet of fencing and wants to build 3 adjacent rectangular corrals. Determine the dimensions that should be used to maximize the area, and then find the area of each individual corral. All right, so what we have here, I'll try to maybe sketch this out. We want 3 adjacent corrals, so we need here and here approximately. So I don't know what this is, but this is x, this is x, this is x. It's a rectangular corral, and the whole perimeter, or the fencing, is 200 feet. So I've used 4x feet here, x feet here, x feet there, 4x feet, which tells me that I've already used up 4x. If I have 200 to start with, and I used up 4x, I have to use half of what's remaining here on this long side and the other half up here. So this turns out to be 100 minus 2x. So now I have the width, I have the length. And what I want to do now is I want to use that to try to find the maximum area. Well, area, and I'm going to call this, because I used the variable x, A of x is length times width. So I'm going to put the x times the 100 minus 2x, which is distributing and kind of flipping it around, negative 2x squared plus 100x. Now, that's a quadratic function. A is negative, which means that it opens downward. The vertex is going to be a maximum point, and that's what we're trying to do, is we're trying to maximize the area. So I need that vertex, and I need that x value of that vertex. Here's A, and here's B. X is equal to the opposite of B, all over 2 times A. So that's going to be negative 100 divided by negative 4, or 25. So I have 25 here as my x, and that means this is 25, this is 25, this is 25, and this is 25. That's 100 feet of fencing. So there's 100 left over. If you plug 25 in, that tells you that this is 50. Now, and this is 25 here. So the area of the whole pen would be 50 times 25, length times width, but we want only one corral. So the area of one corral is 50 times 25 divided by 3. Because there are 3 identical corrals, as far as their size, identical corrals. So I have to multiply 50 times 25, I got to get a calculator out, and then I'm going to divide that by 3. That's 1250 divided by 3, 416, no, actually 416 and 2/3 exactly, not approximately, exactly. So, let's answer it. The area of the corral is that many, and this would be in square feet. And that would be the area of one corral, and that's the answer to the problem.